In this homework, we are practicing our multiple representations of motion. For each situation, our motion is represented in 4 different ways. We have to take a look at what information was given, and we have to figure out the rest from that. In the first situation, we are given a motion diagram. So we have to interpret the motion diagram and then complete the other representations. So what is this diagram telling us? Well, first of all, we have the origin here, and we have the positive x direction, which is west. At event 1, the object is located a short distance from the origin. It moves in the positive x direction, so it moves west. We can see that the spacing of the dots is close together, so it's moving slowly. At event 2, it stops. At event 3, it's in the same position. So between 2 and 3, it did not move. And then between 3 and 4, the spacing of the dots is much larger, so it's moving faster. And it's moving in the negative direction, which would be east. In both intervals, the spacings between the dots stay the same, and so it is moving with a constant velocity. So let's use these ideas to put together the rest of the representations. The order we do this in doesn't matter, so let's start with the velocity graph. Between interval 1 and 2, the object is moving slowly in the positive direction. So our velocity values on this side of the time axis are positive, and on this side are negative. Since it's moving slowly, the values will be close to the 0. And since the velocity is constant, it will create a horizontal line. Between event 2 and 3, the object is at rest. So there's a sudden change in velocity. The velocity is now equal to 0. We don't have any more information about how much time it spends. So any amount that still allows us to draw the rest of the diagram is fine. So there's event 3, and from 2 to 3, its velocity is equal to 0. Between 3 and 4, it's moving in the negative direction now. The spacing is large, which means it's moving fast. So that means the velocity is going to be negative, and it's going to be farther from the 0 to show fast. The velocity is constant, so it's a horizontal line up to event 4. And there's a sudden change in velocity. So our velocity graph is now complete. Let's go to our position graph. Referring back to the motion diagram is helpful because the velocity graph doesn't show any position information. At event 1, our object is located a short distance from the origin. So there's event number 1. It's moving slowly in the positive direction. So it's moving with a constant velocity. It's going to be a straight line pattern. It's moving slowly, so the slope of the graph will be shallow. So from event 1 to event 2, the graph looks like this. The slope is positive, meaning it's moving in the positive x direction. Between events 2 and 3, the object is at rest. So on the position graph, if it's at rest, its position is not changing, its velocity is 0, and so it should be a horizontal straight line. Now between 3 and 4, the object is moving quickly in the negative direction and gets most of the way back to the origin. So quickly in the negative direction, so the slope will be steep. And there is event 4. Now we can complete the word description. So in interval 1 to 2, the object is beginning a short distance from the origin. It is moving slowly in the positive x direction, which is west. It's a straight line, so its velocity is constant. For interval 2 to 3, the object is at rest. For interval 3 to 4, the object is moving in the negative direction, so that would be east quickly. We have a straight line or equal spacings in the motion diagram, so the velocity is constant. And that completes our set of 4 representations. If you're looking at an earlier version of the homework page that has the velocity vectors at the bottom, we are leaving those out.